This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on derivatives and tangent lines. Quick algebra review. We want to find the equation of the line through the point 6 comma negative 2 with a slope of 1/2. So we have an x value of 6, a y value of negative 2 for our point, and a slope, or m, of 1/2. We're going to go ahead and use slope-intercept form, y equals mx plus b, and our goal will be to solve for b. We will plug negative 2 in for y, 6 in for x, 1/2 in for m, and then go ahead and do the computation to solve for b. A half of 6 is 3, so we get negative 2 is 3 plus b, subtracting 3 from both sides, and we have negative 5 is b. And again, we're going to use y equals mx plus b to write the equation of the line, substituting in the 1/2 for m and the negative 5 for b. So this will be y equals 1/2 x plus negative 5, or y equals 1/2 x minus 5. This is a strategy we're going to use to find the equations of tangent lines. So let's continue. Our next example says find the equation of the tangent line to f of x equals 2x squared minus 6x plus 1 at x equals 3. The derivative of 2x squared minus 6x plus 1 is 4x minus 6. The slope of the tangent line is the value of the derivative at 3. So m, the slope, is f prime of 3. Plugging 3 in for x, 4 times 3 is 12, minus 6. We get a slope of 6. So the slope of the tangent line is 6. I also need the y value. I'm told that the x value is 3. What is the y value of the original function? We're going to plug 3 in for x into this equation, 2x squared minus 6x plus 1. 2 times 3 squared minus 6 times 3 plus 1. 3 squared is 9, 9 times 2 is 18, 6 times 3 is 18. We get 18 minus 18 plus 1, or y is 1. So at x equals 3, y equals 1. That's a point on the tangent line. And the slope of the tangent line, m, is 6. So this is the information we have. We have a point and we have a slope. Then let's use y equals mx plus b, plugging in 1 for y, 3 for x, and 6 for m. So 1 is 6 times 3 plus b, 1 is 18 plus b. Subtracting 18 from both sides, negative 17 is b, and m is 6. We want to get the equation of our line. We're going to again use y equals mx plus b, plugging in the 6 for m and the negative 17 for b. That will give us y equals 6x plus negative 17, or y equals 6x minus 17. Our next example is find the equation of the tangent line to f of x equals 4x squared times the natural log of x plus 5 at x equals 1. And I first want to focus on the slope of the tangent line, which will be the derivative evaluated at x equal 1. So we've got to find f prime of x, that is the derivative with respect to x of 4x squared times the natural log of x plus 5. And the derivative of the sum is the sum of the derivatives. So we'll take the derivative of 4x squared log x plus the derivative of 5. But the derivative of 5 is just 0. We think of f of x equals 5 as a function. It's a constant function. It's horizontal. Its slope is 0. So the derivative is simply going to be the derivative of 4x squared log x, which will require us to use the product rule. Remember, the derivative of a product, derivative of uv, u prime v plus uv prime. So we'll let u equal 4x squared and v equal natural log of x. The derivative of 4x squared is 8x. The derivative of natural log x is 1 over x. And again, our rule for the product rule, u prime v plus uv prime, u prime v, 8x times the natural log of x, plus uv prime plus 4x squared times 1 over x. But 4x squared times 1 over x is just 4x, so I get my derivative function. F prime of x is 8x natural log of x plus 4x. But I want to get the equation of the tangent line, so we're going to plug 1 in for x to find that slope. There will be 8 times 1 times the natural log of 1 plus 4 times 1 will be the slope of our tangent line. But what is that? Natural log of 1 is 0. So we get 8 times 1 times 0 plus 4. Of course, our slope of our tangent line is 4. Our x value is 1. We don't know what the y value is that corresponds to that x value of 1. I will find that by plugging 1 into this function to see what the y value will be. So y is f of 1, 4 times 1 squared times natural log of 1 plus 5. Natural log of 1 is still 0. So this will be 4 times 1 squared times 0 plus 5. So our y value is 5. X value is 1. Y value is 5. Slope is 4. So we can consider our point 1, 5 with our slope of 4. As always, using y equals mx plus b, plugging 5 in for y, 1 for x, and 4 for m. We're going to go ahead and solve for b. So 5 equals 4 times 1 plus b. 5 is 4 plus b. 1 is b. But again, that's not our answer. Our answer is going to be the equation of the line. We have a slope of 4. We have a y-intercept of 1. Plugging that into y equals mx plus b, we will get y equals 4x plus 1. Our next example is going to require implicit derivatives. We want to find the equation of the tangent line to x squared plus 2xy plus y squared equals 9 at the point 2, 1. Just a quick check. 2 squared is 4. 2 times 1 is also 4. And what is that? 1 cubed actually is 1. So 4 plus 4 plus 1 indeed is 9. So we need to find dy dx. dy dx will be our slope here. So we're going to take the derivative with respect to x of both sides. So starting with this, the derivative with respect to x of x squared plus 2xy plus y cubed is the derivative with respect to x of 9. The derivative of the sum is the sum of the derivatives. Derivative with respect to x of x squared plus the derivative with respect to x of 2xy plus the derivative with respect to x of y cubed is the derivative with respect to x of 9. The right-hand side is the easiest. The derivative of a constant function is always 0. So now we're here, and we need to go ahead and evaluate each of those derivatives. First off, the derivative with respect to x of x squared is just 2x. Variables match. The derivative with respect to x of y cubed, the derivative of something cubed, 3 times the something squared times the derivative with respect to x of y, which of course is just dy dx. And this middle piece is going to require us to use the product rule. So we'll let u equal 2x, v equal y. U prime, we have to consider the derivative with respect to x of 2x, which is just 2. V prime is the derivative with respect to x of y, which is dy dx. So for this middle piece, we'll go u prime v, 2y plus uv prime plus 2x dy dx. And our goal is to solve for dy dx. That will give us the formula for our slope. So I don't need these parentheses anymore. I can rewrite that as 2x plus 2y plus 2x dy dx plus 3y squared dy dx is 0. And then I want to isolate the dy dx's. You'll notice I want to get all the dy dx's on the left side and everything else on the right side. So subtract 2x from both sides, subtract 2y from both sides. This cancels, this cancels. What's on the left-hand side will be 2x dy dx plus 3y squared dy dx. What's on the right side will be negative 2x minus 2y. So we have successfully isolated the dy dx on the left side. Now factor out the dy dx. So we're going to have dy dx times parentheses 2x plus 3y squared parentheses equals negative 2x minus 2y. And to solve for dy dx, we will divide both sides by 2x plus 3y squared. And we have a formula for dy dx. But we want the slope of the tangent, so we're going to plug in a 2 for x and a 1 for y. On top, negative 2 times 2 minus 2 times 1. On the bottom, 2 times 2 plus 3 times 1 squared. That will be the slope of our tangent line. So indeed, our slope is dy dx evaluated when x equals 2 and y equals 1. Negative 2 times 2 minus 2 times 1, negative 4 minus 2. It looks like negative 6 upstairs. Downstairs, 2 times 2 is 4, plus 3 times 1 squared is 3. It looks like 7 downstairs. So you get a slope here of negative 6 over 7, and we were given our original point of 2, 1, if we have a slope and a point, we can find the equation of the line. Using what? Using y equals mx plus b, plugging in 1 for y, negative 6/7 for m, 2 for x, plus b. So we get 1 equals negative 6/7 times 2 plus b. That would be 1 equals negative 12/7 plus b. Adding 12/7 to both sides, 12/7 plus 1 would equal b. Then we're going to add 12/7 to both sides. 1 is 7/7 plus 12/7 would be 19/7. 19/7 is b. And m is negative 6/7. So if we have the slope m and we have the y-intercept 19/7, we can get the equation of the line by plugging m and b into the equation y equals mx plus b, or y equals negative 6/7 x plus 19/7. And that will conclude this lesson.